Hello students. Yesterday we were discussing mechanical vibration. So we will just start with the lecture. Okay. So first we will just briefly discuss whatever we have discussed yesterday. So then we will start with today's lecture. Okay. So just we have discussed what is the introduction about mechanical vibration, terms used in vibration, types of vibration, then so these things we have discussed yesterday. Today we will discuss types of free vibration and critical or whirling speed of a shaft. Okay. So briefly I will just discuss what all we have discussed yesterday. Okay, and then we will go for today's lecture. Okay. So we have just started with what is vibration. So what do you mean by vibration is just we have discussed if you take any example, any elastic body or a shaft or a disc. Okay, so if you consider a spring and if you just pull it, okay, what it will do is it is to and fro motion, or it can be given by an this graph from this mean position. So this is the mean position. From this mean position, a to and fro motion or up and down motion from a mean position is called as vibration. Okay. So if you consider any elastic body, a spring or a shaft or a disc, so that is any elastic body such as a spring, beam or a shaft is displaced from an equilibrium position by the application of force is called as an vibratory motion. Okay, see this thing we have discussed. Okay, and why we need to study the vibration? Because it increases the stress and energy loss. So there is a need to study about the vibration, and we need to reduce the vibration because the vibration is usually it is undesirable. So we need to reduce the vibration because it causes a lot of stresses and energy losses. So we need to reduce the vibration. So there is a need to study about the vibration. Okay, so this is the example, that is spring. If you just pull it or if you give just a initial displacement, what it will do is it will cause a to and fro motion or up and down motion, which is given by this graph. Okay, so this graph from equilibrium position there is a to and fro motion is called as an vibration. Okay, so then we have just discussed about what all the terms used in a vibration. You know that if you just take an example of a spring, and okay, it can be designated, this vibration can be given by this graph. Okay, from equilibrium position. So now we will discuss what all the terms are there in a vibration. If you just consider this, okay, if you just consider this in a one time period, how much the motion is completed in one time period, whatever the motion completed, this is called one cycle. Okay, this is called one cycle. So okay, then what is the time taken to complete this one cycle is called as time period. So the time taken or time interval required for a system to complete one full cycle. What is one cycle? See, this is one cycle. Whatever time taken to complete this one cycle is called as time period. Okay, this is called as time period. Next, cycle. What is cycle? See, whatever the motion completed in one time period, vice versa. Okay, so whatever the time taken to complete this one cycle is called time period. Okay, and whatever the motion completed in one time period is called as cycle. Okay, and then frequency. See, what is frequency? So number of cycles, if you are taking 1 second, okay, how many number of, if in 1 second, if it is completing only one cycle, then frequency will be 1. Okay, if suppose if I take in 1 second, if it is completing 2 cycles, if it is completing 2 cycles, then frequency will be 2. Okay, so if suppose if I take in 1 second, if it is completing, okay, if it is completing 3 cycles, then frequency will be 3. So what is frequency? Frequency is nothing but number of cycles completed in 1 second is called as frequency. And then coming to amplitude. What is amplitude? So amplitude is nothing but it is a maximum displacement from this equilibrium point. See, this is the maximum displacement or a maximum distance covered by a particle. See this, if I just take a particle is moving like this. See, this is covering the maximum displacement or a maximum distance from this main position is called as amplitude. See, usually time is nothing but it is given in seconds, okay, and usually frequency it is measured in terms of hertz, okay. So you have understood what is terms used, that is period, cycle, frequency and amplitude. So okay, these are the terms used in vibration. Okay, we will just go to next types of vibration. Suppose, okay, if you are just taking a spring, okay, and if it is vibrating, if you are keeping it in a air, and if it will have a small vibration, so that is such type of vibration is called free or natural vibration. You are not applying any force, there is no external force, okay. If it is vibrating on its own or because of air or anything, then it is called as a free vibration. Understood? So then forced vibration, okay, same spring is there, same mass is there, if you are applying a force, because if you are pulling it, okay, then such type of vibration is called as an because of external force, then such, if force is there, then it is called as forced vibration. Understood? Free vibration is nothing but if it is vibrating on its own, there is no force, okay, then such type of vibration is free vibration. Okay, if you are applying a force additionally, if you are applying it, okay, if this force is there, then it is called forced vibration. If external force is there, then it is called forced vibration. Okay, next is damped vibration. It is same, you are having a spring, okay, you are having a force, you are having a if you are having a mass, if you are using additional damper, okay, what is damper is to reduce this vibration we are using this. If you are using this damper, such type of vibration is called damped vibration. So you have studied three types of vibration, that is free vibration, forced vibration, okay, if you are using force then it is forced vibration, damped vibration, if you are using a damper then it is called damped vibration. Okay, these are the three types of vibration. So now next we will be discussing, okay, and this is damping, how you are using. See, you can just see, observe that there is a vibration, there is a reduction in the vibration. See, it is goes on reducing. So by using a damper, okay, so that type of vibration is called damped vibration. In this today's lecture, we will just discuss what is types of free vibration. You know what is free vibration. So we have discussed here what is free vibration. No external force, you are not using any force, okay, directly. If it is rotating, if it is vibrating, it is called as free or natural vibration. In this types we will study what are the types of free vibration. Okay, I have considered one shaft, okay, okay, these are the that is different types of free vibration are longitudinal vibration, torsional vibration, then transverse vibration and torsional vibration. Okay, so now we'll just discuss one by one, that is longitudinal. I'll just consider one spring or a shaft I have taken. You can take shaft or a spring. Okay, if I just consider this shaft, okay, I'll just consider this shaft. Okay, this is one shaft I am considering. Okay, if this is the axis, okay, suppose this is the axis, here it is there, okay, if this is the axis, and if I consider, okay, if I consider a particle here, okay, if I just consider a particle here, okay, if the vibration is like this, okay, if the vibration is like this, okay, how the vibration, if the particle is moving, okay, if the particle is moving up and down, okay, if it is moving up and down, that is, if the particle of the shaft or a disc moves parallel, see how the particle is moving parallel, okay, it is parallel to this axis, okay. If this axis, how it is moving, it is parallel to the axis of the, if it is parallel to the axis of the shaft, then it is called longitudinal vibration. Understood? Longitudinal vibration. Okay, second we will discuss transverse vibration. What do you mean by transverse vibration? If suppose I'll consider same shaft, I'll consider, okay, I'll consider a particle here, and I'll just consider a axis, okay. So I'll just consider a axis, okay. If suppose if it is moving like this, okay, suppose if it is moving like this, okay, if it is moving like this, okay, how it is moving, this particle is moving here, so how it is moving, so it is moving like this. So if it is moving perpendicular to the axis, this is the axis, it is moving perpendicular, okay, it is not parallel. If it is perpendicular to the axis, okay, it is so this will be transverse, okay, sorry, it is wrong, okay, it will be transverse, okay, it will be transverse, okay. How it is moving, so it is moving transverse direction, then it is called as transverse vibration. If it is moving perpendicular, or you can consider one more example, that is if you consider a simple pendulum you have seen, okay, if you are considering a pendulum, okay, and if you just vibrate it, how it will come, it will come here, okay, then it will go here. How the particle, if you consider this as a particle, okay, how the particle is moving, particle is going here and particle is going here, and this is the axis. If you just consider this as the axis, it is perpendicular to the axis of the shaft, okay, perpendicular to the axis of the shaft, then it is called as transverse vibration, okay. Then we'll just take next is, okay, this is wrong, okay, this is torsional vibration, torsional. So what do you mean by torsional vibration? Okay, we'll just consider here, okay, if suppose if you are having a shaft, okay, and if you just consider a particle here, okay, and if this is the axis, okay, if it is rotating, okay, if it is rotating like this, so if this is the axis, okay, and if the particle, if this particle is there, no, if it is rotating like this about the axis, then it is called as torsional vibration. See, when the particle of the shaft or a disc is in a circle, okay, that is about the axis, if it is circular, if it is moving circular about the axis, then it is called torsional. So there are three types of, okay, free vibration. One is longitudinal vibration, if the particle is moving up and down, okay, that is parallel to the axis of the shaft, then it is called longitudinal vibration, okay. If it is perpendicular, to the axis, okay, if it is perpendicular, that is 90 degree to the axis, see this is the axis, and if it is moving perpendicular to the axis, then it is called transverse vibration, okay. If it is moving circle about the axis, this is the axis and it is moving circular fashion, okay, if the particle is moving circular fashion, it is called as torsional vibration, okay. These are the three types of free vibration. So understood, okay, that is longitudinal vibration is parallel to the axis, transverse vibration is nothing but perpendicular to the axis, torsional vibration is nothing but in circle to the axis of the shaft, okay. So these are the three types of vibration, okay. So we have briefly discussed what all things, okay. So we have briefly discussed about, what is vibration, then the terms used in vibration, that is cycle, okay, time period, okay, then frequency and amplitude we have discussed, then types of vibration, that is free vibration, okay, then forced vibration, then damped vibration. Under first one, free vibration, we have studied three types, that is longitudinal vibration, okay, then transverse vibration, and we have studied last one is transverse longitudinal, okay, longitudinal, transverse and torsional vibration. These are the three types of free vibration. And last concept that is remaining is critical or whirling speed of a shaft. We will just discuss. Okay, so I will just discuss what is critical or whirling speed of a shaft. Okay, for this I'll just consider, okay, so I'll just consider one shaft, okay, which is under a bearing. It is fixed here, okay, and it is fixed here. Okay, this is the shaft. I'll consider one plate here, plate or a disc I'll consider, and I'll call this point as an O point. Okay, when it is under stationary motion, it will be like this. Okay, if I just start rotating this shaft, what happens? If I just start rotating this shaft, see, it will be, see, this bearing will be fixed, this bearing will be fixed. Okay, now what happens? This shaft, when it starts rotating, so it will rotate in this fashion, correct? So it will start rotating. This plate will come here, or this plate will come here, and this plate will come here. So now the what is the critical speed is the speed at which shaft runs, so that this deflection, see, this is called deflection, whatever the, see, it will be 0 here, so it will be here only shaft. Now the shaft has come here, see, this is the point, it was there previously, it was there. From here, this, if I just take this as a deflection y, so then what is the deflection here? The speed at which additional deflection, this deflection becomes deflection of the shaft from the axis of the rotation. See, this is the axis of the rotation. From this axis of the refraction, if this y, if it becomes infinite, that means if when it is rotating, so vibration becomes so high that this, okay, this y becomes infinite, okay, this becomes very large. So this y becomes very large, that is infinite. Such speed is called as a critical speed. Such speed is called as a critical speed. The speed at which this y becomes very large, okay, because of that vibration it becomes very large, and there is the chances of failure, okay. So such type of vibration is called, such speed is called as an critical or whirling speed. So you can just see here, when a shaft is stationary, okay, there is a shaft here, okay, and there is a rotor or a plate, okay. So now when it starts rotating, so rotating, what it becomes is, see, here it will it will move this like this, okay. Here, this, whatever the this is the axis of the shaft. From the axis of the shaft, there is a deflection here, there is a deflection which becomes infinite, okay, it becomes infinite. So such speed is called, that speed at which it becomes infinite, so that speed is called as an critical or whirling speed of a shaft, okay. Such speed is called as an critical or whirling speed of a shaft. So this will be the axis of the shaft. From this axis of the shaft, this deflection becomes infinite, that is more, okay, it will become more. Why this happens is because of vibrations, okay. If it is rotating simply, okay, it will not cause a whirling speed, okay. If it is not properly mounted, then it will be, so under vibration, because of that vibration, this y becomes very large, and it will cause, okay, this shaft to okay, damage, okay, and that there is a chances of getting shaft get damaged. Such type of vibration, because of that vibration, this critical or whirling speed will happen. So critical or whirling speed is nothing but the speed at which, okay, the deflection becomes infinite or more, okay, that is called as a critical or whirling speed. This can be denoted by these two diagrams, okay. So what you need to do is, you need to just okay, remember the definition, and you need to just okay, draw these two diagrams to explain critical or whirling speed. Okay, so in this so we have just completed in this lecture, we have just completed all these parts. Okay, I hope you have gone through all this and you have understood. That is, so what is vibration we have studied, then the terms used in vibration, that is cycle, time period, frequency and amplitude we have studied. Then what all the different types of vibration we have studied: free vibration, forced vibration, and last is a damped vibration. Under first free vibration we have studied what all the types, that is without any force, what all the types are there. That is, if a particle is moving, okay, that is parallel to the axis, then it is called longitudinal vibration. If it is, okay, perpendicular to the axis, this is the axis, and if it is perpendicular to the axis, it is called transverse vibration. Okay, if it is moving in circle, in a circle fashion about the axis, then it is called as an, okay, it is torsional vibration. Then we have studied critical or whirling speed, the speed at which, okay, the deflection becomes infinite, or that there is a chances of shaft to failure. That speed is called as an critical or whirling speed. Okay, so we have just covered all these things in this part of a lecture. Okay, thank you.